You know, when you mentioned being fascinated by AI that can reason, I knew we had to dive into this Don Lim article.
Oh, absolutely.
It's from September 2024, so it's really fresh off the press.
Okay.
And it breaks down some really interesting stuff about OpenAI's newest models, o1-preview and o1-mini.
Yeah, Lynn does a great job of kind of explaining how these models are different from what came before. You use this analogy of System 1 versus System 2 thinking.
Right.
Have you come across that before?
I have.
Okay.
Yeah, it's like the difference between reacting instantly and actually stopping to think something through, right?
Exactly. A lot of the AI we've seen, even impressive stuff like ChatGPT, has mostly been System 1,
Right.
quick reactions, pattern recognition.
Yeah.
But these new models from OpenAI are being called System 2 LLMs because they're designed to mimic this more deliberate step-by-step thought process.
Mimic being the key word there, right?
Right.
It's not like these AIs are actually understanding things the way we do.
Right. It's important to keep that in mind. What's fascinating is how they're achieving this more human-like reasoning.
Okay.
Lim dives into the technical details, explaining how OpenAI is using a method called chain of thought, or quarter.
Okay, so let's unpack this Cody thing. How does that actually work?
Imagine giving the AI a set of specific instructions for how to approach a problem,
Okay.
kind of like a recipe for thought. Each instruction is a step in a chain, leading the AI through this logical sequence.
Okay.
And these instructions are coded as what are called reasoning tokens.
So these tokens are like commands for the AI's brain.
Precisely. And what's really cool is that OpenAI has designed these tokens to be somewhat human readable.
Okay.
So instead of seeing just a jumble of code, you might see phrases like, let's test this theory, or, that seems unlikely, appear as the AI is working through a problem.
Wait, seriously?
Yeah.
So it's like we get a glimpse into the AI's thought bubble.
In a way, yes, Lim actually includes a really interesting image in the article.
Okay.
It's a screenshot from one of OpenAI's models showing this chain of thought in action, complete with those human-like phrases.
That's wild. But even though they look like words we use, they're really just instructions for the AI, right?
Exactly. They're still system tokens in disguise.
Okay.
But presenting them this way gives developers a better understanding of how the AI is processing information.
Right.
It also makes it easier to spot errors in the AI's reasoning.
That makes sense. But you know what else is interesting?
What's that?
Lim mentions that using these reasoning tokens actually costs money.
It does. It's not just about the final answer anymore.
Right.
It's about paying for the AI's entire thought process. Each token represents a step in that chain of thought.
Yeah.
And those steps add up.
So it's like we're paying for the AI's brain power, not just the results of that brain power.
Yeah.
That's interesting.
It is, and it raises some intriguing questions about the future of AI development. But
Right.
before we get too far ahead of ourselves, Lynn points out that there's a lot more to these System 2 models than just reasoning tokens. OpenAI is using some other clever techniques as well.
Oh, like what?
Well, one that stood out to me was the concept of a decision gate.
A decision gate. Okay, I'm going to need you to break that one down for me.
Sure. Think about it this way. The AI could keep generating thoughts and exploring different chains almost endlessly, right?
Right.
But at some point it needs to decide, okay, I've thought about this enough. Here's my answer. The decision gate is like the AI's internal mechanism for making that judgment call.
So it prevents the AI from going down an endless rabbit hole of possibilities.
Exactly. It helps the AI reach a conclusion without getting bogged down in an overwhelming number of options.
Right.
And for us, the users, it means we get a clear, concise answer without having to wade through pages of the AI's rough drafts.
That makes sense. I mean, imagine if Siri gave you every possible route to your destination, even the ones that involved going through 3 states and a cornfield.
Right? We need that filtered, refined output, and that's where the decision gate comes in. But there's another really important aspect of how these models learn and refine their reasoning. Reinforcement learning, or RL.
Ah, yes. The AI equivalent of practice makes perfect? But how does that work with something as complex as reasoning?
That's a great question. With RL, the AI isn't just being judged on whether its final answer is correct or not.
Right.
It's getting feedback on every step of its thought process.
So it's like having a teacher looking over the AI's shoulder saying, good job using that reasoning token, or maybe try approaching this step a different way.
Exactly. And the AI uses that feedback to constantly adjust its approach, getting better at choosing the right reasoning tokens and building more logical chains of thought.
So even though it's called artificial intelligence, there's still a very real human element in teaching these AIs how to think.
Absolutely. And this is where Lim highlights another technique OpenAI is exploring. System 2 attention.
Okay, I'm intrigued. What is System 2 attention all about?
You know how when we're trying to solve a problem, we don't focus on every single detail equally?
Right.
We instinctively pay more attention to the things that seem most relevant or important.
Right, like when you're trying to assemble furniture, you might focus on the instructions and the parts in front of you, not the random stuff your cat dragged in from the other room.
Exactly. System 2. Attention is about teaching the AI to do the same thing, to prioritize information and allocate its processing power to the most critical aspects of the problem.
So it's about working smarter, not just harder.
Precisely. It's about helping the AI focus its artificial mind on the things that matter most, just like we try to do.
That makes a lot of sense. And I think I'm starting to see how all these pieces fit together. The reasoning tokens, the decision gate, the reinforcement, learning the System 2 attention. It's like a whole orchestra of techniques working together to create this illusion of thinking.
It is. And to really illustrate how this could play out in the real world, Ling gives a fascinating example in the article. Setting up Wi-Fi in an entire stadium.
Ooh, that's a great example. Talk about a logistical nightmare. You've got the shape of the stadium to consider potential interference, not to mention thousands of devices all trying to connect at once. I can see why this would be a challenge for even a really smart AI.
Right. And in the past, this would have been a massive undertaking for human engineers, taking weeks or even months to plan and execute properly. But with this new generation of AI, Lim suggests it can be done significantly faster and potentially even more effectively.
Okay, I'm all ears. How would the AI tackle a problem like this?
Well, first it needs to understand the problem, right?
Right.
And this is where those specialized reasoning tokens come in. Lim gives some great examples like tokens for analyze environment, identify coverage needs, and even assess interference to account for all those walls and electronics that could mess with the signal.
So we're basically giving the AI a toolkit of commands to make sense of this complex situation?
Exactly. And once it has a grasp of the problem, it can move on to the planning stage. This is where you might see tokens like determine AP locations, figuring out where to put those Wi-Fi access points, consider mounting options, and plan wiring.
It's like the AI is a whole team of engineers rolled into one.
It really is. And it gets even cooler. Remember how you mentioned the challenge of simulating thousands of devices connecting at once?
Right.
Well, the AI can actually do that too.
No way. Tell me more.
Using reasoning tokens like generate traffic patterns, the AI can simulate a full stadium of people using their devices. It's like running a virtual stress test on the entire Wi-Fi system before even a single cable is run.
That's incredible.
Yeah.
But what happens if the AI runs into problems during this virtual test?
That's where the real learning comes in. The AI can use tokens like monitor performance to see how the simulated network is holding up. If it detects bottlenecks or weak spots, it can go back, adjust its plan, maybe add more access points, or tweak the signal strength. And this whole process, the simulating, testing, refining, is something that will be far more time-consuming and expensive to do in the real world.
It's like the AI is able to learn from its mistakes and improve its design in a way that would take human engineers much longer. So we're not just talking about better Wi-Fi here, we're talking about a whole new way of approaching complex problems.
Precisely. And that's what makes this whole field so exciting. But as with any new technology, there are also challenges to consider.
Right, because as much as I love the idea of AI that can design Wi-Fi networks for stadiums, I have a feeling it's not all smooth sailing from here. What are some of the hurdles that Lim talks about? So as amazing as it sounds, it's not like we can just unleash these reasoning AIs on the world's problems just yet. What are some of the hurdles that Lim talks about?
Well, one of the biggest challenges right now is the sheer amount of training data these AIs need. Think about it. We had to show the AI how to approach that stadium Wi-Fi problem step by step.
Right.
But there are countless other problems we might want it to tackle, from designing bridges to optimizing traffic flow, and each one would require a similar level of detailed instruction.
So it's not just about teaching the AI how to think in general. We have to teach it how to think about all these specific domains, which is a massive undertaking.
It is. And right now, a lot of that teaching falls to human experts. We need people who understand these complex fields to essentially show the AI what good reasoning looks like in each context.
Right.
Lim even mentions a 2023 OpenAI publication where they talk about using human feedback to refine these chains of thought.
It's almost like we need to create a whole curriculum for AI reasoning school and find enough teachers who can grade the AI's homework at every step.
Exactly. And that raises another challenge, scalability. If we're relying on humans to train these AIs one problem at a time, it's going to be very difficult to scale up this technology to address the truly massive and complex challenges facing the world.
So the million-dollar question becomes, can we automate that training process? Can we teach AI to learn good reasoning without so much human hand-holding?
That's the crux of it. Lim doesn't offer an easy answer, and I think that's by design. He leaves us pondering this question about the nature of reasoning itself.
Right.
Is it something we can ultimately break down into a set of rules and procedures that a machine can learn? Or is there something fundamentally human about it that might always elude even the most advanced AI?
Now, that is a thought-provoking question. I mean, if we can crack the code of self-learning reasoning AI, the possibilities are pretty much limitless, right?
Absolutely.
Yeah.
But if we're limited by the speed at which humans can train these systems, then the true AI revolution, the one where these machines are helping us solve some of humanity's biggest challenges, might be further off than we think.
It makes you appreciate both the incredible progress that's being made in AI and the profound questions that still lie ahead. This deep dive has definitely given me a lot to chew on. Thanks for walking me through this fascinating and slightly intimidating world of thinking machines.
My pleasure. A constantly evolving field, so I'm sure we'll have plenty more to unpack in future deep dives.